Hello friends, my name is Aditya Chaturvedi. My roll number is 2015 BEN055. I'm from class SYIT and my college is Walchand College of Engineering. So today I'm going to discuss something about Ethernet frame. Now what is Ethernet frame? Now basically dividing this word into two parts, Ethernet and frame. Let me focus on Ethernet first. What is Ethernet? Now a system for connecting a number of computer systems to form a local area network with protocols to control the passing of information and to avoid simultaneous transmission by two or more systems. Now, looking at this definition at a time, it will be a bit confusing for you. So let me explain you with the help of an example. Now, suppose here is internet, computer, hub, computer 2, game console, computer, and again a printer. Now let me take a pen so that I can explain you on a better way. Okay, so here we go. Now this computer 1 and this computer 2 are actually connected by a hub. Now this hub is basically responsible for communication between an internet, computer, game console, computer 3, computer 2 and the printer. Now if you see that these are all connected by these wires. Now these wires are basically Ethernet. Now these wires are Ethernet cable. Now why are these Ethernet cable? Because these are providing us with connections between all these devices. So basically all these devices are connected to hub, and hub is establishing a connection between all these things with the help of this Ethernet cable. Now how is this Ethernet cable useful? Now basically these are gonna follow a set of rules. Regulations, which you can say that it is basically working upon for its communication medium. Now these simple rules and regulations are called as protocols. Now there can be various types of protocols like ICMP, which is Internet Control Management Protocol. Now these protocols are not just same everywhere. For using LAN and WAN, you have TCP as a protocol. Okay, you may have UDP as a protocol. You may have ARP as a protocol. Okay, so basically these type of protocols are actually working upon this topology. Now what this topology is responsible of? This topology is working upon these like for internet, when you have two routers, we can go for Internet Control Management Protocol. Then we have LAN, like computer 1 and computer 2, when these are actually connected via LAN. Okay, now this is going over here. So when this connection is set up through an internet cable, it is going to go for TCP or UDP. So when these connections are done, these are working on several protocols. So Ethernet works as a transmission medium between these all communications. So let me go back to the definition again so that it can be very clear to you again. So now what is Ethernet? Okay, let me take a pen again. Ethernet. Now Ethernet is basically a system for connecting number of computer systems to a local area network with the help of protocols to control the passing of information and to avoid simultaneous between two or more systems. Basically a system which connects a number of computer systems in a local area network with the help of protocols for the passing of information and avoiding simultaneous transmission of two or more systems, which is basically termed as collision. Sorry for that. So this is basically termed as collision. Okay, so I hope now the definition is quite clear that Ethernet is basically a system which is for connecting number of computers from a local area network with the help of protocols to pass information and to avoid simultaneous transmission between two or more systems, which is also known as collision. So after getting this thing clear in our mind, what is Ethernet? Let me go to what are the types of Ethernet. Now basically Ethernet has various types like 10-base-5, 10-base-2, 10-base-T, 10-base-F. These are basically the codes which is given to different types of Ethernet cables. So instead of going to all at once, let me go for one single example and let's take it 10-base-5. Now a 10-base-5 is called as thick Ethernet 4. Now why is it called as thick Ethernet 4? It is because now if you compare, this is 10-base-5 diagram. Now this is a photo of 10-base-5. You can see the thickness. The thickness is quite huge in compared to 10-base-2 and 10-base-T. Now, what are the advantages of 10-base-5? 10 base 5 is, first of all, it is a resembles as yellow garter, which is based on its appearance. Second, marking for every 2.5 meters means, like, if this is a wire of 5 meters, so at every 2.5 meters there'll be a marking which will say that 2.5 meters is over. Okay, so that is quite efficient in terms of usage of wire, how much you have used. Now connections are basically made on these like connections are basically made on vampire tapes. Now looking forward to this vampire tapes, we'll look onto this term on the video again, or if you can go for it, you can search in Google also. Now if you go for can run for 500 meters, it is actually that a wire may go for a particular length of distance. Now if this is the distance, okay, this is suppose 100 meters, if its capacity is 100 meters, so after 100 meters you will need to establish a repeater over here so that it can re-amplify the signals and again transport it. Why we need a repeater over here is because the signal which we are transporting is gonna be affected by noise. Noise is gonna affect it, then thermal resistance is gonna affect it, degradation of quality is gonna affect it, and lots of other factors are gonna influence the quality of data. So by the time it reaches to the end, it needs a repetition or amplification so that the data can be transferred safely and successfully to different locations. So 500 meter is a limit for this 10 base 5, and it can also handle 100 machines. Now my friends, 100 machine is quite a very huge number, because 100 machines, it means large corporate houses will be using it for different purpose, where there will be very heavy data flow, and 10 base 5 is very capable of handling such scenarios. Now as I have taken example of 10 base 5, let me go for other in that, like why Ethernet is so famous. So in terms of the evolution of Ethernet standard has 10 Mbps of speed, which is a standard Ethernet. We have other type of Ethernet called as fast Ethernet, which is 100 Mbps of speed. We have 1 Gbps of Ethernet speed. We have achieved 10 Gbps of Ethernet speed through wire cable, but it is still in research mode. It is not at all in a commercial market right now, but companies like Google, Facebook, Tesla are actually working upon this and are known to be exploring this idea and using it currently, and will be launching it in the market very soon. But looking forward to these, they are very influenced, they are very much into the market, and you can very easily find them, especially 10 Mbps and 100 Mbps are very efficiently used in a household. 1 Gbps can be seen in colleges and corporate houses where they need high data transfer flow. So this is a very common real life example. If you can see, you can notice it elsewhere in your nearby surroundings. Moving on to the next topic, which is standard Ethernet. Now what is standard Ethernet? Standard Ethernet is like standardization for Ethernet, like what kind of Ethernet protocol, like framework or structure which should be followed over here, so that the world has there should be a standardization around the world. So looking for the history, the original Ethernet was created in 1976 at Xerox Palo Alto Research Center, which is PRC. Since then, it has gone through 4 generations. And the generations which I have already mentioned over here, which is standard Ethernet, fast Ethernet, gigabit, and 10 gigabyte Ethernet. Those are the generations. Okay. Now we're gonna briefly discuss upon standard Ethernet, and we are gonna go with this standard following, which is IEEE standard, which is an international organization for giving standardization for all these protocols and frameworks. Now looking forward to this is the most important part, which is IEEE 802.3 frame format. Now this frame format is the format of Ethernet, which has a preamble, which has an SOF, a destination address, source address, length, header and data, and FCS. FCS stands for frame check sequence. The full form of SOF and frame check sequence are given here. You can mention this. Now if you see, permeable is 7 bits, SOF is 1 bit, destination is 6 bits, source address is 6 bits, length is 2 bits, and data stands for 46 to 1500. So, and frame check sequence is for 4 bits. Now my friends, looking for this, I'll be going to each and every term over here in detail at what all these stands for. But can you just guess what is the total length of the whole frame? So if I add these numbers, I get the total as 7 plus 6, 1 plus 6 plus 6 plus 2 plus 46 plus 4 is equal to 72 bit. So which means that the whole frame, this whole frame over here is actually gonna go for 72 bits. So the whole frame size is 72 bits. In general, it can vary due to this 46 to 1500. I have taken minimum as 46 over here. It can extend up to 1500. Okay, so let me give you a clear view again about the whole frame. So let me erase the markings which I have made over here. Now, if you see properly, there are basically permeable, destination address, source address, length, header and data, frame check sequence, and this start of frame delimiter. So these are basically sorry my friends, this is not bits, it's actually bytes. Okay, so basically this preamble, destination address, source address, length, header of data, and FSS. I'll give you a very small introduction of source address and destination. Basically these addresses are addresses source from where the frame is sent, and destination from the where the frame is going to reach. Length will stand for the length of the whole data which we are putting in over here is going to be stored in length. Frame check SOF framework will be discussing here. So let me go on to the next slide. A preamble. Now what is a preamble? Looking forward to the definition. In digital communication, preamble is a sequence of known bits sent in each frame. This is a sequence of known bits. Okay, now this is 8 bytes. A sequence of known bits 10 10 10 10. You have all those things. It is used for frame synchronization such as Ethernet frames as well as for channel estimation. Now why do we need synchronization? Suppose a frame is being sent from like source. Okay, let me give you an example. This is suppose a source, and let me take over here, like this is suppose a destination. Now it is connected by a Ethernet cable. Okay, now suppose they want the source A wants to send a frame to source B. Okay, and at the same time source B wants to send a frame to source A. Now when these two will go, don't you think the preamble digits or the frame digits, whatever data they have, whatever the header they'll have, they'll match, or whatever communication is any type of data. Suppose if I go with the example of permeable, or if I say like frame check sequence, if I say start of frame delimiter, or the preamble itself, this bits may be same. In this case, these bits actually provide synchronization about this frame structure, where you can actually guess what kind of preamble it is. So this preamble will not be copied into the frame which is being sent by B, and they'll have a unique preamble. So this is where it it appoints a sequence. Second, whether the channel is busy or not. So this bit will store the information of what kind of frame number it is, what kind of frame content it is, what kind of frame number it is, what kind of identification it is. Now how this will happen is, the number of contents, the number of changes you will see in this byte is going to affect this decision making process. Now what is SFD? SFD is basically an 1 byte value, which is an 8-bit value that marks the end of preamble. So if you see in this diagram, here it is still 10101010, it is ending till here, and 11. Now this is basically saying that now here the preamble ends, and from here we'll be having the start of your frame. This is the main job of SOF. So you can see the SOF always stands after preamble. So SOF here's preamble is here, it is just 1 bit. It is going to say that the frame is starting, and the next option is going to be destination address. Now looking forward for destination address, SFD as I've already explained. Source address has a destination address. Now it has a 6-bit, 2 bytes or 6 bits. We are going to go for 6 bytes because 6 bytes is what we are going to go for IEEE standard. And 6 bytes, there's going to be an address number for the destination port, destination address for the system. Now what happens is, the only unique thing behind destination addresses, for ordinary addressing, the higher order bit is 0. So 0 means signal up, and for addressing called as multicasting, where you need to go for multiple systems at the same time, the higher signal bit is 1. And here the higher bit signal is 0. So high signal in single to single system communication is going to be 0. Higher signal for one to many type of communication is 1. Same goes for broadcasting, where you have to send 1 to all. Now in this case, multicasting means 1 to many but selected many. Broadcasting means 1 to all without any prior selection. In this, higher signal is 1, and in ordinary it is 0. So keep in mind, because this is a difference between This is now moving on to the next topic. Let's go for a further revision where we have length. Now, what this length basically counts on. If you see the frame structure over here, which is the like it is the shrinked format, you have length of 2 bytes. Now, why this is 2 bytes? Now, whatever length you have over here, like 46 to 1000 of your data, the data's length will be stored in this slot. So the data you have and the padding you have out of that, the length of data is going to be stored in this length type. This is where length is being developed. So nothing more to explain on this. This is a very general and very generic type of slot over here in the frame. Now preamble is clear, SFD is clear, start of frame delimiter, where it shows the preamble has ended, the start of the frame has started. Destination address is clear, source address is clear, length slot is clear, that this is the length of data. Now what is data? So data is basically your actual content which you're gonna show and which you're gonna put it in the frame and you're gonna send it via Ethernet. Now why we need padding over this? Now out of 46 to 1500, suppose I fill up only till 1200. So out of the 1200, padding will be gone for 300 bits. So 1500. Now why this padding is necessary? Padding is basically necessary to fill up the empty spaces over there in the structure, in the frame structure, so that balance has been maintained in the frame. So data, and so basically this whole slot for 46 to 1500 is totally dependent on the data which we have. Now frame check sequence, this is very important part of the frame. It is basically related to all kinds of security and whether your frame is being manipulated or not. Moving to the next topic, frame check sequence. A frame check sequence refers to the extra error detecting code added to a frame in a communication protocol. Frames are used to send upper layer data and ultimately the application data from a source to a destination. Now what this basically says, let me explain you with a simple example. Now suppose this is our source and this is our destination over here. What happens is, this is your Ethernet. Now this Ethernet is sending a frame. Okay, and this frame is gonna travel to this Ethernet, it is gonna travel and it is ultimately gonna reach to the destination. Now suppose its frame check sequence is 101. Now I am a hacker and I track this frame in between by any means. Okay, and I manipulated the frame with some means, like anything. Like if I manipulate the data, I manipulate the frame sequence, I manipulate the preamble, I manipulate the source address, I manipulate destination address. In that case, automatically this frame is the FCS, which we are talking about, frame check sequence. Now the destination will know what is the frame check sequence number of this frame, will know. It will now what happens as soon as the manipulation of this detection is, like when the manipulation is, this frame will change, the frame check sequence number will change to suppose 1 0 and suppose 0. Okay, now in this case, okay, 1 0 and 0. Now in this case, when the frame will reach to the destination is gonna match 100 to 101, which it knows that the frame check sequence is 101. In such case, what will happen is it will find that this is not at all equal. Now when this is not at all equal, the destination system will come to know that this frame is being manipulated, and thus there is an extra error detecting code. Now in the error detecting code is added to the frame, so which is this FCS. Now this code, if there's an error, there's manipulation, there's a check, if the frame is being corrupted or something, so this code will automatically change or it may differ from its standard code, and when this is compared, the destination will get to know this frame is not reliable. I will ask for a retransmission to the source again. This is how frame check sequence work, which is a very important part of it, and it is also part of this communication protocol. So this is all what what are we going to study for our Ethernet frame structure. So let me show you the photo again for our frame structure, which is a preamble, which is also of 7 bytes. We have start of frame delimiter, we have destination address, we have source address, we have length of the data, we have data and its header, with padding, and we have frame check sequence. So this is all about the Ethernet frame structure. Thank you.